And with us today, we've got Dave Kadenoff as a tech support expert with Ideal, and Chris Forthouse. He's the senior product manager for test and measurement with Ideal. And Bob Fox is with us also. He's our national accounts manager for Crescent Companies. So with that, I'm going to turn it over to Chris, and at the very end, we will address any questions that we have come up. So go ahead and type those in at the very bottom. You'll see a Q&A. You can do chat if you wish, and we will answer questions at the end of the presentation. So thanks again for your time. And with that, I'm going to turn it over to Chris.
All righty, Carl, thank you. Thank you, everybody, for joining us today. We're going to take you through kind of an instructional and tech explanation of our Ideal SureTrace Circuit Tracer. There's 3 kits. We can answer questions about specifics later, but that's really what we want to do today is inform you about really how it works, how it can be used not only for tracing, but for troubleshooting as well. Also, we'd like to make you aware of, there's actually a dedicated website out there, and it's www.idealcircuit-tracer.com. And the reason I bring this to your attention is because there are a number of 3-minute how-to videos to use this for some of the things that we're actually going to be covering today or talking about. So I want to make sure you're aware that that's out there. Also on that particular site is a quick reference guide, which will give you kind of a step-by-step on how to use it to find breakers and fuses, splice errors, etc. So good resource tools, get a lot of good feedback on them. Just want to make sure you know they're out there. So today what we want to cover is really we want to make sure you understand how the circuit tracer works and how it can be used to troubleshoot. And then we'll open it up for questions. Or if there's any questions along the way, please feel free to put those in and we'll answer them. One of the things that we found out from talking to a number of contractors and electricians is that there's a profitability challenge today, right? And that's due to the rising material costs, the code changes increasing material costs, and thus faults due to human error. And then the fact that troubleshooting, when you get in a troubleshooting situation, service situation, it often turns into a budget or schedule busting activity because you really don't know what you're going to encounter. And there's a number of different reasons for that. Some of them below: identifying a fault condition and location, partial demolition of newly built structures, and then it requires all kinds of work. You got functioning rough-ins, and they're rendered non-functional by the contractors that follow you prior to the final trim. And then you get the seasoned supervisor that gets called to assist the mid-career electrician or unseasoned journeyman to resolve issues. So there's a number of different things that can complicate the whole profitability piece. And then the other thing is the troubleshooting skills in particular among electricians. What we hear is they're declining, and that's expected to further increase labor costs. And why is it? Well, you got experienced electricians retiring, good 401ks, professional electricians really evolving into 2 types. You've got a construction electrician and a service and maintenance. More of them are going towards the service side, and then the demand for electricians and construction schedules are really prohibiting a lot of on-the-job training in service and troubleshooting, and then also the schools are being challenged to kind of make up that gap. So hopefully these are some of the things that you all are seeing out there as well, and that's why we think there's really some value in going through what the tracer can be used for. This particular diagram here is one that we've come up with to kind of exaggerate or illustrate how troubleshooting can actually become schedule busting. This is basically a flow chart that I did with a licensed electrician, 25 years in the field, and we did this to kind of lay out all the steps that would be required to find out why a light bulb wouldn't work if it wasn't the light bulb. So you can see that, you know, it can become pretty complex, as most of you know. So the bottom line is that understanding how to use a circuit tracer can help you save time and money, and it can be used to find breakers and fuses, splice errors, dead shorts, wires and walls, ceilings and floors, even coax, cable, and buried conductors to a certain extent. So we want to go through some of this with you today. The value of the circuit tracer, a lot of folks ask us, do we have any case studies? Well, here's an example of a case study that showed the ideal SureTrace, how it saves the electrician a significant amount of money in a year. If you figure a single electrician 2 hours, 2 times a week, that saves them basically $17,000 in a year, and the math is all there. This is based on some work we did back in 2017 that showed electricians most commonly spend up to about 2 hours on troubleshooting. So, and then on top of that, there's troubleshooting occurring about 1 to 3 times a week. So again, there's some validity in how the circuit tracer can help save you some money. The other thing is it can actually help you make money. By saving the troubleshoot and fix problems, you accomplish more jobs per day, basically. So what we've done here is said, okay, normally you can execute 5 service calls and you're yielding about $110,000 in revenue from that, where if you can double your service calls, you can basically double that revenue. Pretty simple, and it's probably somewhere in between, but this gives you kind of a high and a low in terms of the costs that you can actually, or the revenue you can actually generate. So how does a circuit tracer work? Well, basically there's a transmitter, which is over here, and it basically sends out the signal, which is placed on a conductor with adapters, with an adapter, alligator clips, or an inductive clamp, and it sends that signal down the line. And then you have a receiver, and that receiver basically is tuned to that same signal. It senses a signal strength and then determines the strength in order to identify the signal running on a conductor or to identify a breaker. It's fairly simple. And the nice thing about our tracer is no matter what you use it for, it always comes down to the transmitter sends the signal. And if you hook the transmitter up to the right, the conductors the right way to get a good signal down the line, the receiver will find it. One of the things that we like to use is this analogy of hot and cold. When you were young, you probably played the game hot and cold. And one of the things that we've heard from our end user base is that our particular tracer, the way it's used, we have about a 15 to 20 inch range, where if you think about the further away you are from the conductor, the colder you get, but the closer you get, you can see the numbers changing here in the dial. Till you get right on. 99 is the highest number you can get on the receiver. But as you pass that conductor and go to the other side, the number starts to fade off. So you know that you're doing your swipe, you can come back to the middle. And like I said, the feedback that we get is because of the range we have, you don't have to be right on top of the conductor. You actually have some leeway with how far away from the conductor you can actually use this to pick up the particular signal. In this particular case, what we've got depicted here is how a circuit tracer works to find the breaker. In this example, we're able to take the adapter kit that comes with the plug that in the transmitter. It basically, again, sends out that signal, and then you have the receiver in your pocket. Let's say in this particular case, you're up on the 2nd floor and you've plugged your transmitter in, and it's a commercial building. Most of your breaker panels are down in the basement, right? So you basically take the receiver and you leave it on the highest setting, which would be 4 bars above the dot. And you take it down in the basement with you, and you would run this over each respective panel. Then the panel with the breaker in it is the one that's going to have the highest reading on it. In this particular case, it's going to be 90 something, most generally 80, whatever, but it's the highest reading out of those panels. Then what you do is you open up that breaker panel, and using the sensitivity button, you would bump down the sensitivity to what we call the breaker finding mode, where actually 1 bar above the dot is the lowest setting, and you scan the breaker panel just up and down the panel. And what we recommend is that point at which the conductors come into the breaker is the best point to put the tracer, the receiver, and you just scan up and down, and the breaker with the highest signal is the actual breaker that the transmitter is tied to. The other thing, and Dave will show you this a little bit later, is that we have what we call a certain circuit identification. If you notice in the transmitter here, we don't have the lightning bolt lit up, but the light would light up on this, or the lightning bolt would light up, and there's a lightning bolt in the receiver. And what happens is there's a second signal going from the transmitter to the receiver. It basically lights up a lightning bolt over here as well. And again, like I said, Dave will show you this. But what happens is that also indicates that there's a live circuit. So when you find the correct breaker and you shut this particular breaker off, the lightning bolt will go off in the receiver as well as the transmitter, and you're down in the basement. So basically, you know that you have the correct breaker because the lightning bolt went out. If you got the wrong breaker, the lightning bolt does not go out. So it's a time saver from that perspective. You really only need one person to do the breaker finding in that particular case. So that's how it works to find a breaker. Again, simple concept: transmitter sends out the signal, goes down the conductor into the breaker, and then what you're looking for is the highest reading in the breaker panel. They're in the brochure that we referenced earlier that's downloadable. This is an example of what's in there, but this basically summarizes what I just went through for you. It takes you through step by step what you need to do to find the breaker in the energized panel. The circuit tracer can also be used to find faults that cause tripping breakers. Something that's come in since the advent of the code changes with AFCI, GFCI combo breakers or common splice errors that cause nuisance tripping of those particular breakers. Also, you see in the second picture here, a dead short condition, or sometimes you get in a hurry and forget to stick that ground wire back in the back of the box, and it comes up around and shorts out on one of the lugs. You've probably seen or had screws run through your conductors. This happens a lot with some of the guys when they're hanging cabinets, for example. And then also in lighting, we've had a lot of requests for folks to tell us how, if it can find a short at neutral. In this particular case, that's what we've got here. Is we've simulated a short neutral to ground where the can was pushed up, pinched the neutral, and has shorted out the light circuit there. So when you use this for finding the dead short conditions, all of which were kind of just summarized earlier, the first thing you want to do is start out with a continuity test. And you're all familiar with the continuity test. You know, it's a check to make sure to see the circuit, that their current flow, it's complete. Well, that's also a situation with a dead short, right? So with the continuity test, you basically run the continuity test and confirm that you have the shorted or shared neutral condition on those conductors. What that does then is that tells you which leads, which conductors you actually want to put your lead set on for the transmitter. So you would literally take, in the case of splice neutrals, you've got two neutrals that have passed the continuity test. You'd basically, with the alligator clips in the kit, clamp those onto the respective neutrals, and then turn the transmitter on, and it'll allow you to find that splice neutral condition. This is a better example of or what we call a common splice error. But what we've done here, basically, again, the transmitter is going to send out the signal. We've run the continuity check across these two neutrals to verify that there is continuity between these two, so we know that they're touching somewhere along the line, or they're run together. In this case, you can see by the diagram that it's over here. So once you do that, what it's going to do is going to send a signal out both of those neutrals, and where those neutrals come together, you're going to get the highest reading. So when we've actually done this out in the field, mostly they tend to be under what, lights or devices under the plates. And basically what you do is, once you connect this, you go into that respective room and you just place the receiver over those particular devices, and the device where the splice neutral or splice error is actually will be the highest reading. So you don't have to pull the covers off all the devices in the room. You don't have to pull the wires out. You basically just use this to actually scan over those devices and the receiver will identify it. It actually takes us longer to take the panel off, hook up the transmitter, verify with the continuity check, and hook up the transmitter to send the conductor than it does to scan the room with the tracer to find the respective splice error. And then to fix that, you just separate the neutrals, right? So that's how it's used to find a common splice error. And again, you know, there's this pattern here where it's the transmitter knowing how to hook it up to the right conductors and then using the receiver to find things. And again, in the brochure that we referenced earlier, these are the steps. So you can see it takes you through it 1, 2, 3. How it works to find a dead short. Again, there's a reoccurring pattern here. In this particular case, we've got a breaker that's tripping. It's because we've got a dead short that's been caused by a ground wire touching the hot lugs. We've got a hot to ground short. So we've done our continuity check and verified we've got continuity here between the hot and the neutral, and basically clamped the transmitter receiver on, on, and then turn it on, run the signal through the conductors. And again, if you remember, when it comes together, that's where you get that hottest signal. You scan all these outlets, and when you get to this one, that's where you're going to get the highest reading. And that's because that receiver sensing it. Now, in this case, and the one prior to, these are de-energized circuits. So there's no lightning bolt or anything like that going on. And again, finding the dead short is identified here in the brochure. Takes you through step by step. Also, how to find it, the neutral to ground dead short. Same type of situation where you get a breaker popping and it's in your lighting circuit. Again, you do the continuity check, verify that you've got the continuity across the appropriate conductors, hook up the transmitter, send the signal out, and you scan the actual light fixtures. What we found when we're using this to scan light fixtures, sometimes you have to scan around the respective light fixture a little bit to get the strongest reading to verify it, but it definitely will show higher at that particular affected lighting fixture compared to the rest of them. And then again, finding the dead short in is here. It's described in the manual. Finding a dead short on 3-phase. Again, this is de-energized, but you'd use a multimeter or clamp meter to confirm the circuit is de-energized. Perform the continuity check. Again, attach the transmitter with alligator clips where the continuity was found. Then you scan the wires away from the transmitter. And we recommend the 3rd sensitivity setting until you get the highest numeric reading on the receiver. And then your receiver will indicate the likely location of the fault. And then once that fault is located, you can troubleshoot or repair it. How it works in walls, ceilings, floors, again, the same way. You plug the transmitter in, you send that signal along those conductors, and you use the receiver to trace it. In this particular picture, what I've done here is we've got the receiver with the strongest signal here. But if you were up here away from the particular conductor that has a signal on it, you notice the further you get away, again, you're at like 55. Down here, you could be at 45. And as you scan over the conductor that you're actually tracing, that's where you'd get the highest reading. And so you can basically go down the wall this way and identify your particular conductors. And again, this is also in the quick reference brochure that I referenced earlier. COAX plates the same way. Again, here, if you have a COAX you're trying to find or identify and you're down in a box, basically, if you can strip back a little bit of that insulation and you clamp onto the center, the copper core, and then you get onto the shielding on the other side, you actually create the signal running through there, and you can trace the COAX that way. And then when you get down into the actual box where everything's coming together, it's that particular COAX that has that highest reading is the particular COAX you're looking for. And with that, I'm going to turn it over to Dave and let Dave do some actual demonstrations and discuss the physical unit itself. Dave?
Great, thank you. I'm just trying to get my camera larger to the, instead of my as if it was viewing me. I want to try to share it. Oh, let's see how we can do this. I'm sorry. Can you see this okay?
Yeah.
Yep, you can? Okay,
Yes.
if you can see that, okay, great. We'll just start that. Ladies and gentlemen, thank you for joining us for this. So in front of me, what we have here is the transmitter and the receiver. Transmitter, just as a very quick recap, 0 to 600 volts, AC or DC. So DC, of course, is self-evident, but it's 50 or 60 hertz. Never plug this into the output of a variable frequency drive as just one example, because that will ruin. We'll just say will ruin the unit. It is fuse protected, but it's AC or DC, 0 to 600 volts, 50 or 60 hertz. So we'll go ahead and turn the unit on. Of course, just in the top, you have 2 terminals that you would plug your leads into, and we'll go through the leads here in just a minute. And we turn it on. Now, Chris was saying that there is an icon above of lightning bolt. So when we plug this into light voltage in a minute, that light will light up, showing that it is sending an additional signal, as Chris described. And then here's the receiver. So obviously it's audible and it's analog. You can see the analog scale, but it's also digital. So instead of having just 5 or maybe 10 LEDs, it's got 0 to 99 scale. Well, that makes it very, very sensitive. So I'm going to move these apart. And as you can see, as it twists a little bit, the display rotates in 90-degree increments. So as you're undulating up and down a wall or what have you, you're going to see, I'm going to shut that sound off just for a second. So there obviously is a mute button on there. And what I want to demonstrate first is just how sensitive this is. Hopefully it'll stay oriented towards me. My table's warped just, you see it's warped just a little bit. There's a little ball in there that determines which way is up. So I'll just hold it like this just to keep it up. So what I want you to notice is right now they're about 10 inches apart or so. But what I want you to notice is how far do you have to move it to see if you're getting closer to or further away from the source. And this is with nothing plugged in, of course, as you can see. And what you'll notice is I'm moving it essentially 1/4 of an inch or less, and I can tell whether I'm getting closer to the source or further from the source. So that's just how powerful this is. So once you get used to just how sensitive this can be, it can be an extremely powerful tool to find all sorts of issues. And again, Chris probably talked about this, but because this is sending out an electrical signal, you can broadcast that against, through rather, anything that's electrically conductive. We've sold these to plumbers to locate where copper tubing is, copper pipe, I should say, doorbell or alarm wire, anything that's electrically conductive. Fish tape, you can jam fish tape down an empty PVC conduit and loop it back with another wire so you have a complete path, a complete loop, send the signal down, find out where the end of the buried PVC is so you know where to dig it up to continue affecting repairs or continue an installation. We've seen that happen in times gone by. I also want to show you something. This is directional. So if you notice, I'll turn the sound back on here just for a second. So what you're going to notice as we spin it around in some directions, it's very, very powerful. And in other directions, you can see it'll almost go to 0. Hopefully you can see I don't want to block the view. So part of the key to learning this, and as you get one of these and start working with it, is understanding you can't be waving around. If this line that you might be able to see this line represents a conductor that's behind a wall, and you're doing this kind of a pattern trying to scan, you're going to have a terrible time. What you want to do is find the high point, and I'll demonstrate that again in just a second. You want to find the high point, center it, then spin it around and find the orientation that gives you the strongest signal. And now you've confirmed, people say it makes no sense that it's pointing this way. And unfortunately, it looks like an arrow. So people that, oh, it must be over there. Oh, it must be over there. Oh, it's back over this way or up there or up here. Don't do that. Keep it flat against the surface when that's appropriate, or over the ground, for instance, and then keep it, and then find the orientation that gives you the strongest signal. Tracing is all about broadcasting a very strong signal and then receiving that signal. And that's really the trick to keep in the back of your mind. So with that, we have a series of, I just want to show you a couple of things here real quick. It comes with an adapter. So you can see this plugs into the top. This plugs right into an outlet. I want to make sure you can see that. And it comes with 3-foot leads. I had those here. Oh, here they are. So alligator clips with 3-foot leads. So you can plug, so if you're clipping onto like a 480 volt 3-phase system, as an example, those come with it. It comes with a series of adapters. So you get 2 blade and 1 ground pin. So those will plug in, so you can use that if that's what makes sense for your particular application. So it comes with a complete set of leads, so you can affect whatever kind of repairs you're trying to do. So now what I'm going to do is bring this over, and this is just an outlet that I have plugged into a live circuit. I'm going to plug this into the top here. And you can see the instant I plug that into a live circuit, you suddenly get the, you instantly get that live indication of live voltage there. So that then, and if you noticed, now that's the lightning bolt that Chris was speaking about before. That, you know, as soon as you unplug, that goes away. As soon as you plug it back in, that sends an additional signal that lights that up. And that allows you to confirm that you've got, that you're broadcasting the signal onto the branch circuit that you're trying to identify. So again, when you shut the breaker off, that goes out, you know you shut off the right breaker. Now, I want to arrange this in such a way, if the transmitter is too close, you can't demonstrate it because the signal goes everywhere. So I'm just going to bring up some extension cord here. So we'll lay this down. I'm going to turn the sound back on. Now we're in the highest setting right here. So obviously people say, well, what do I start in? I tell people just start in the highest setting. If it's 99 everywhere and you can't tell what's going on, step it down a step. Okay, so now you imagine if you could imagine that the wire itself is behind a wall, for instance. So we're going to come in from the side. So if you saw that effect, those of you that are in the know would understand that that's due to the twist in the wire. And it's just, again, this is just a broadcast antenna, but it's a twist as it goes through. So again, patience is also important as you start to get used to any kind of tracing. So as you find the center line, you can step it down, and that'll let you get closer and do a more accurate job of finding the actual center line. Now, don't be fooled by that nulling out. It's going to 0. I understand that. But that, again, that's because of the twists in the wire in this particular cable. So, but you can see just how accurately this is going to tell you where you want to be. And if this was just a like Romex cable and it was just single conductor, it would be even much more precise than that. I've myself have located here. Let's shut that sound off. I myself have located conductors that were in metal conduit under a few inches of concrete floor to within ½ an inch. So again, under the right conditions and under great conditions, it can be very, very powerful. So then next, what I wanted to show you was this guy. So I'm going to shut the transmitter off. So that signal should go away like you would expect. And of course it did. And additionally, we have this inductive clamp. I'll put the battery pack here. I'll turn that back on. So this is a battery pack with 8 C cells in it. This is an inductive clamp that would clamp around a conductor. And then of course you've got the receiver. So you can see just how powerful this is. Now, this inductive clamp, just if you choose this option, just remember that this is only useful for up to 120 volts carrying 5 amps or less. Beyond that, the signal gets overpowered by the current flow in the conductor. and it doesn't, it just simply doesn't work. But for certain applications, it can be very powerful. And you can always add that later. If you buy the unit, like the 61955 or 957, you can always add the inductive clamp and battery pack at a later date if you feel that you need it. So, oh, and one last thing I wanted to show you. Now, we don't sell this, but I'm going to show you how easy it is because one of the slides actually referenced something like this. So what this is nothing more than an L620, not outlet, but plug rather. And what I did was I took a regular set of multimeter leads. Since the transmitter itself just takes standard 4mm safety banana jacks, I made this up out. I cut the probes off a couple of multimeter leads, wired them to the 2 hots in this, and now I have an adapter. And we've been asked, well, why don't you sell these? Well, because we don't get a lot of requests for this, but if you've got applications that have certain kinds of plugs, you could make up your own plugs. Just get yourself, like I keep saying, multimeter leads, wire it up, and you'd be good to go. So just a little trick just to make things a little bit easier on you. So with Chris, I think, is there anything else that I missed that that might be of interest?
No, Dave, I think you covered it. I think we're ready for questions if there are any, or if anybody's got any comments.
Yes, back on the bottom of your screen, this is Carl. Back on the bottom of your screen, if you just kind of hover over the bottom, you should be able to type in a question if you want to ask Chris or Dave any questions pertinent to the tester itself and troubleshooting in general. So if you've got any questions or you want to plug something into chat, it looks like we've got something. One comment, very thorough. Thank you.
Thanks, Ted.
You're welcome.
And as Chris mentioned at the beginning of the presentation, if you weren't able to join us at the top of the presentation, that we will include some links to some additional troubleshooting 3-minute videos that that you could plug in and look and do your own troubleshooting, if you will. Just kind of a self-coaching, if you will. Does it work well with MC? We have a question.
Well, metal clad will attenuate or dampen a certain portion of the signal. I've traced through metal conduit, and the trick is it live or is it de-energized? Is it a dead short? Is it open? So yes, it will, but you have to be, you can't be, 10, 15 feet away. You have to get fairly close to see exactly the where that is. But yes, it does work with metal clad. People often ask too, well, can I just put the signal onto the out of the shield itself, on whether it's a datacom cable or MC? Well, you have to be careful because people often, this is something we deal with all the time, people put it from hot to ground. And well, once you put it on the ground, you basically found the building. The signal goes everywhere and it becomes confusing. So there are all kinds of techniques, some of which are covered in the video, some of which we encourage anybody to call in and say, I have this application or I'm trying to do this, and we help you through it as best we can. So
we have one other question. What distance can the inducer function in underground tracing?
Now, the inducer, to me, when you say inducer, this is the inductive clamp. You probably mean the transmitter. And if that's the case, now you can't take this to the bank, but I've had one report where they were picking up the signal 4,000 feet away. And this was on a golf course. And I believe it was control circuits for sprinklers. Having said that, hundreds of feet easily on an energized and closed loop. If it's de-energized or open loop, then a lot of the strength comes from this transmitter, from the signal being able to exit one terminal, go through whatever it is, and whatever the loads are, the branch circuits and the loads, and coming back to the other terminal. So even doing something as installing a light bulb will close the loop. If you go to an outlet further down and close the loop, then the signal can go down the hot through the filament and come back. Anything like that, if you think about it that way, then you have a much stronger signal, I should say. So,
Dave, the other thing I would add to that is in regards to underground, you know, there's a depth element to this as well, besides the distance. And, you know, we've had, from a distance standpoint, I've really never had anybody give me a distance limitation. I know we had an industrial situation where the circuit was a quarter mile away and it was affected. But again, it's because there was a good solid circuit there. So the answer on distance is it's situational, right? The other part of it is that when you look at depth, I have an instance where I have an old farmhouse that we were renovating, and I had a galvanized water pipe buried 6 feet down in the house out to the well, and the power, the UF wire was buried as well. What we were able to do was get, and we had a crack in the pipe, so it had to be replaced. We had to find it. So we hooked the transmitter up with a vice grip on one end of the water pipe, and then we got one out to the other end at the well, and then with some TNN wire, hooked the other end up with a vice grip, ran it back in, and hooked the transmitter up on it. And the signal strength was really strong. And again, you would think with 2.5-inch galvanized pipe, the pipe happened to be 6 feet down. The substrate was sand and clay, so it was pretty clean. In that particular case, we were able to put a flag every so many feet, and when we went down to dig with the backhoe, it was dead center on that particular pipe. But again, it's situational, right? Because Dave's talked a little bit about it, but it depends on the substrates. For example, if you're trying to trace what conduit in something that's filled full of rebarb, there could be some instances where it's a little bit tougher, right? So again, it's situational, and a lot of it depends on the substrate.
I was in an apartment building one time, and I was with one of the electricians down in the sub basement in the electrical room, and they went to the top of the building, which, as I recall, was either 12, 13, or 14 floors, plugged in the transmitter and said, "Okay, go." And they challenged me, "Go ahead and find which breaker," and it was a large breaker because it was all the way up, and we found it. So. Again, but it was energized, and again, it worked just as we would expect it to. So that was nice.
Dave, there's another question here about the inducer having less power, and would think they're probably talking about the clamp.
Yep. Okay. By less power, do you mean the limitations that I meant about this? Does it well work with MCI? No. Yeah. Less power. Does the inducer have less power? The strongest, okay, here's the way I'm going to answer that question. The first way to do it is always hook directly up anytime you can to the hot and neutral, or if it's three-phase, face-to-face. That's you're always going to get the strongest signal that way. This is very, very powerful, but what happens is because if you put this around a conductor carrying more than 120 volts and or more than 5 amps, it starts acting like a current transducer. And at a microscopic level, it'll start chattering and you'll hear it humming. And every time it chatters with that 60 hertz waveform that we deal here with in the United States, that opens up at a microscopic level. And every time it opens up, the signal bleeds off. So it's counterproductive to have this on and this opening up at a high frequency when you're trying to induce a signal onto a conductor. So that's why its limitation is simply, like we keep saying, 120 volts and 5 amps. I hope that possibly answered the nature of the question. It's very powerful, as you saw. I'll shut this guy off. I'll turn this all the way up, and I'll plug this in. And you can see it goes right to 99, and I can move this right across it. It's now 2-3 feet away. This is still 99. So the signal is very powerful, but it's always more powerful to put the signal onto a live circuit that's close. Because I keep repeating.
Okay, we do have another question.
Yes, there is a handle to prevent you from crawling. So
that's a great question.
Yeah, that is. That's a very good. You have right onto a broomstick, and what's that? The CR-959, I think, Chris?
I think that's what it is. It's called a cradle. Yeah, and you basically put the receiver in it, like Dave was talking about, which screws into the cradle screws into the bottom of a broomstick. There's pictures in that brochure using it for parking lot wire tracing, and you can see the cradle being used. That's available as an accessory.
Yeah.
We will have this recording available afterwards. And what we'll end up doing is including links to some of the stuff that Chris alluded to earlier on the troubleshooting videos and the brochure itself, so you can find the broomstick, if you will.
Oh, and on that very note, just very briefly, when I'm outdoors doing underground tracing, I hold it at waist level. Now, you don't want to, again, you don't want to go back and forth, tilt it up and down, but I hold it at waist level, comfortable, and I look at it. And I can do, in most cases, I can do just fine tracing. Once I've found the area of interest that where the problem may be, because don't forget, some runs are 20 feet and some runs are 200 or 300 feet or much longer. Once I found the area of interest, that's when I start worrying about getting down on my hands and knees or use the cradle that you discussed. So again, you don't have to start with a cradle. You can, but I just find it interesting that the signal is powerful enough in most cases. You can just walk along and get a good idea of what's going on.
Dave, do you have a 955 receiver there?
A 955, I do, but I took the batteries out to protect it. So
okay.
Sorry. Yeah, the red. So we have the red.
Yeah, the reason I mentioned that is because there's 3 kits available. The 955 being the opening price point kit, and the receiver is different in that particular kit versus the receiver that Dave has been showing you. This receiver is a 959 receiver, and it's common to the 957 and the 959 kits. This is the more popular one, and it's the one we prefer. It's a little bit easier to use, but there is a an opening price point receiver, and it's red. The display only rotates 180.
Yep.
And there's a couple more. There's another button on it, and that has to do with I think it's checking the batteries. So it's simple to use, but it's a little more complicated to this one, and it's an option. And if you download the brochure, or if you open the brochure up online, the last page of the brochure actually shows the differences between the kits in terms of what's included, and the inside back cover actually explains the differences between the receivers.
And this one simply has more information on it. It is easier to read, but the main reason to not get the red LED is if you're going to use this inside only forever and ever, then the red LED is a potential option for you. But the moment you walk outside, the red LED disappears in sunlight. So we get a number of people that unfortunately they buy it thinking they're saving some money and then want to return it or exchange it or whatever. So if you ever think you might use it outdoors, please don't even consider the less expensive version of this. This is that you want this display either with or without the 2 kits, either just these 2 or the entire kit, the 959 61-959 that includes the inductive clamp.
Yeah. Just to level set, there are 3 of these circuit tracer kits available.
Correct.
We can include that information.
Perfect.
You'll see that in the brochure.
Perfect.
Okay. Well, if we don't have any other questions, if you have any questions, go ahead and type them in, and if you don't, we'll end our webinar. But thanks once again for we do have thanks guys from
we like those comments.
Yeah. Thanks for your attention, Chris and Dave. Great presentation. I think you'll find that contractors and our staff have learned a lot about circuit tracing in this endeavor. So fantastic. Thanks again, and that'll conclude our recording and our broadcast, and we will send this out to all those that were registered but unable to attend, and to those that did attend for sharing with colleagues. So thanks again for a great presentation. Thanks everyone for your time, and make it a great day. All right.
Thanks everyone.
Thank you all.